Hello my friends and welcome back to my channel. Today we are going to be looking at functions questions taken from 2020 papers. I've put the worksheet with these questions in the description down below so you can download it. I hope you're ready to begin, so let's get started. Question number 9 goes, express 2x squared plus 12x plus 11 in the form 2 of x plus a squared plus b, where a and b are constants. So this is completing the square. So I'll write down 2x squared plus 12x plus 11. Okay, so since I want to complete the square, I'll focus on 2x squared plus 12x for now. So this is what I'm going to do. So I'll factor out 2. So that will be x squared plus 6x here. The 11 is here. Then I will open the bracket. Then x here plus half of the coefficient of x. So half of 6 is 3. Then squared. Then I subtract the 3 squared. So I've completed the square on this part, and that's plus 11. Then I'll continue simplifying. This means that I'll be getting 2 of x plus 3 squared minus 9 plus 11. So what I'm going to do right now, I'll skip a line. So this is 2. I'll multiply 2 times x plus 3 squared. So that's 2 of x plus 3 squared. Then 2 times minus 9, that's minus 18. Then plus 11, that's already there. So here, we are now saying minus 18 plus 11, that gives us minus 7. So finally the answer comes out as 2 bracket x plus 3 squared minus 7. So that's how we complete the square for 9 part A. Let's go on to part B of the question. On part B, the function f is defined by f of x is equal to 2x squared plus 12x plus 11 for x is less than or equal to minus 4. Find an expression for f inverse of x and state the domain of f inverse. So they want us here to find the inverse of the function. Now remember, for our f of x, when we completed the square, we got 2 of x plus 3 squared minus 7. So to get the inverse, I'll write it as y is equal to 2 of x plus 3 squared minus 7. And I'll make x the subject. So I'll add 7 to both sides. It becomes y plus 7 here. Then divide both sides by 2. So I have a 2 here. So now I have 2x plus 3 squared left on the right side. Then I will square root both sides. Okay. And if I do so, I'll be having plus or minus the square root of y plus 7 over 2 is equal to x plus 3. And finally, I'll subtract 3 from both sides. So minus 3 plus or minus the square root of y plus 7 over 2 is equal to x here remaining. Then I'll interchange the variables. So y is equal to minus 3 plus or minus the square root of x plus 7 over 2. So this gives us the inverse now. Inverse is minus 3 plus or minus the square root of x plus 7 all over 2. But now while we're here, I would want you to consider that for the function of f, x is less than or equal to minus 4. And from this, we can deduce that the range for the inverse function is also going to be less than -4. Okay, so that's a domain of function and a range of inverse type of relationship. So if the domain of the function is less than or equal to -4, it means the range of the function represented by f inverse of x should also be less than or equal to -4. So the only way that f inverse of x can have a value that is less than or equal to -4 is when we have minus here. So between -3 plus square root of x plus 7 over 2 and -3 minus square root of x plus 7 over 2, the only one where f inverse of x is going to be less than or equal to -4 is when we have f inverse of x taking the value -3 minus the square root of x plus 7 over 2. So this here is the one that we will settle for. So that's the inverse here. Now, they also say state the domain of f inverse of x. Now, you need to know that the domain of the inverse function is comparable to the range of the function. Now, what is the range of the function? The function here is a parabola. The minimum point of the parabola, if you look at the form of the completed square, should be -3 minus 7. We deduce that from the completed square format. Okay, and we're hearing that the domain of the function is x is less than or equal to -4. So this should be somewhere here. Since we have -3 here, -4 should be around here. So what we want now is to know the range, the y values for which the graph is going to be valid. So if x is going to be -4, if that's the x value, then what is the y value? Okay, so it means we can substitute -4 into the function. So if we substitute -4 into the function, you see how we have x plus 3, so that's -4 plus 3, that's -1. -1 squared, that's just going to give us 1. Then 2 times 1, that's 2. 2 minus 7 is -5. So -5 is the value here. So the range for values of x that are less than 4 is going to start from 5 going all the way up. So the range of f is actually y is greater than or equal to -5. And this automatically it becomes the form of the domain of f inverse. So here for the inverse, we are saying f inverse of x is equal to -3 minus square root of x plus 7 over 2. And the domain is going to be x is greater than or equal to -5. It takes the form of the range of the function. So this becomes our answer here for part B. For part C, it goes, the function g is defined by g of x is equal to 2x minus 3 for x is less than or equal to k. On part C, for the case where k is equal to -1, solve the equation fg of x is equal to 193. So here we want to find the composite function f of g of x, and it's equal to 193. Okay, so that means that we're saying is the function of g of x, that's 2x minus 3, should give us 193 here. Now f of 2x minus 3, which is g of x, we know that the function f of x, from what we have, is this. I'll use the completed format. So this is it here. So it means that in place of x, I'm going to put 2x minus 3. So it will now come out as 2 of, in place of x, I put 2x minus 3, and then plus 3, then squared, then minus 7 is equal to 193. So this is going to give me 2 of minus 3 plus 3, that's 0. 2x squared gives us 4x squared. Then minus 7 is equal to 193. I'm going to add 7 to both sides. Okay, so 103 plus 7, that's 200. Then 2 times 4x squared is 8x squared. Then dividing both sides by 8, I get x squared is equal to 200 divided by 8 is 25. Which means that if I square root both sides, I get x coming out as plus or minus of 5. But now that we have x being equal to plus or minus 5, according to the question, x should be less than or equal to k, and k is minus 1. So it means that x should be less than or equal to minus 1. So the value of x here that is less than minus 1 is minus 5. So therefore, I can conclude that x is equal to minus 5. So that's the solution to part C. Let's go on to part D. Part D goes, state the largest value of k possible for the composition fg to be defined. So here we're talking about f of g, which is f of g of x. Now you need to know that the function f has a restriction. If we go back up to part B, the restriction or the domain was that for f of x, x should be less than or equal to minus 4, which means whatever gets into f of x, whatever gets here, should be less than or equal to minus 4. So in our case here, it's f of g of x, which means that g of x, since it's now we are inputting g of x into f of x, should also be less than or equal to minus 4. But we've been given that g of x is 2x minus 3. So I'll say here 2x minus 3 is less than or equal to minus 4. That's 2x is less than or equal to, if we add plus 3 to both sides, we get minus 4 plus 3, which is minus 1. So x should be less than or equal to minus a half. So since, according to this part, x should be less than or equal to k, the maximum value that x should take is k. So in our case here, we can therefore deduce that k should have a maximum value of minus a half. So that's the value, that's the answer to part D. Let us now look at question number 6. Functions f and g are defined for x is an element of all real numbers by f of x is equal to half of x minus a, and g of x is equal to 3x plus b, where a and b are constants. So on a, given that g of 2 is equal to 10 and f inverse of 2 is equal to 14, find the values of a and b. So here we've been given that g of 2 is equal to 10. So how do we handle this? First of all, I will work out g of 2, because for this composite function, g of 2 is an input into g, into the first g here. So I'll work out g of 2 first. So for g of 2, if I go to the function g, it's g of x is equal to 3x plus b, which means I'm inputting 2 in place of x. So g of 2 should come out as 3 of 2 plus b, and that's 6 plus b. So that's g of 2 here. And since g of 2 is an input into the function g, and we got g of 2 coming out as 6 plus b, so it will now be g of 2 is equal to, and we input g of 2, that's 6 plus b, into this, so it becomes 3 of 6 plus b plus b, like it is 3x plus b here. Simplifying, I get 18 plus 3b plus b, and that gives us 18 plus 4b. So this is the expression for g of 2. We also have another piece of information that f inverse of 2 is equal to 14. So we know that f of x, which I want to express as y, is half of x minus a. And I have to find the inverse of f. So I'll first have to make x the subject. So if I try to make x the subject, adding a to both sides and multiplying both sides by 2, I will get x is equal to 2y plus 2a. So I've just made x the subject here. And then I'll interchange the variables. So I'll have y is equal to 2x plus 2a, which means that f inverse of x is actually 2x plus 2a. So I now have the inverse function. And since I have the inverse function, and since f inverse of 2 is 14, it means I'll substitute 2 for x. So for f inverse of 2, this will be 2 of, and I input 2 for x. So that's 2 of 2 plus 2a. So f inverse of 2 gives us 4 plus 2a. So we now have this for f inverse of 2. So from the information given in the question, g of 2 is equal to 10, which therefore means I can say 18 plus 4b is equal to 10, and I can solve this equation for b. So I'll subtract 18 from both sides, so I have 4b is equal to 10 minus 18, and that's going to be minus 8. And I divide both sides by 4, and if I divide both sides by 4, then b will come out as minus 2, and that's the value of b. And from here, the information given is f inverse of 2 is 14. So here, I'll equate f inverse of 2, which is 4 plus 2a, to 14. And so for a, so subtracting 4 from both sides, that will be 2a is equal to 14 minus 4, that's 10. And I'll divide both sides of the equation by 2. So a comes out as 5. So that's the value of a. So we now have our solutions. A is 5 and b is equal to minus 2. So we're done with part A. Let's now go on to part B. It goes, using these values of a and b, find an expression for g of f of x in the form cx plus d, where c and d are constants. So here, they want us to find g of f of x. So this is a composite function, and we know that f of x is an input into the function of g. So what is f of x? From the information given, f of x is half of x minus a. So that's g of a half of x minus a. So I'm inputting half of x minus a into the function of g. And what is the function g? The function g is 3x plus b. So it means I'll be having 3 of x, which is half x minus a, plus b, which is 3 over 2 of x minus 3a plus b. But you know, we had gotten a as 5 and b as minus 2. So therefore, since a is 5 and b is minus 2, then g of f of x will now be 3 over 2 of x minus 3 of a, which is 5, plus b, which is minus 2. So eventually we'll be getting 3 over 2 of x minus 15, that form 3 times 5. So minus 15 minus 2, that's minus 17. And this is the value of g of f of x. So that's the answer to part B. The function f is defined for x is an element of all real numbers by f of x is equal to a minus 2x, where a is a constant. So on a, express f of x and f inverse of x in terms of a and x. So let's start with f of x. This means that is the function of, and we are inputting f of x into the function of f. So that will be a minus 2x here. So whatever goes into the function of f replaces the x here. So that will be a minus 2 of, the input is a minus 2x. So that will be a minus 2a plus 4x, which can be simplified to 4x minus a, since a minus 2a is minus a. So that's the expression for f of x. Then for f inverse of x, we can say y is equal to a minus 2x, and we interchange the variables so that it becomes x is equal to a minus 2y. Then we make y the subject, so y will be equal to a minus x over 2, which therefore means that the f inverse is actually a minus x over 2. So that's the expression for f inverse of x. And that's how we answer part A. Now for part B, given that f of x is equal to f inverse of x, find x in terms of a. So now we are equating f of x and f inverse of x. So f of x is 4x minus a. So here I'll be having 4x minus a, and it's equal to f inverse of x, which we got to be a minus x over 2. So let's simplify this, multiplying both sides by 2 and this side by 2. We'll be getting 2 times 4x, that's 8x, and 2 times minus a, that's minus 2a. It's equal to, these 2's will cancel, so it's a minus x. Then adding x to both sides, we'll be having 8x plus x, and adding 2a to both sides, we'll be having a plus 2a. So that's 9x is equal to 3a, and dividing by 9 both sides, we get x is equal to 3a over 9, which is the same as a over 3, since 3 gets into 9 3 times. So the answer comes out as x is equal to a over 3. And that's how we work out part B. Question 9. The function f and g are defined by f of x is equal to x squared minus 4x plus 3, for x is greater than c, where c is a constant, and g of x is equal to 1 over x plus 1 for x is greater than minus 1. So on A, express f of x in the form x minus a squared plus b. So here, what is required is for us to complete the square. We have f of x here as x squared minus 4x plus 3. And to complete the square, I'll use x squared minus 4x. So here I'll take x minus half coefficient of x, so that will be minus 2 squared, and that will be minus of minus 2 squared, and that's plus 3. So we will get x minus 2 squared minus 4 plus 3, and this gives us x minus 2 squared minus 1. So this here is the answer for part A, where A in this case is 2 and B is minus 1. Let's now scroll down to part B. It is given that f is a 1-to-1 function. State the smallest possible value of c. Now, you can notice that the domain is x is greater than c. And we know already that this is a quadratic curve, a parabola, and it's a parabola in such a way that it's a U-shaped parabola. And the domain is x is greater than c. It means that we are supposed to start from the minimum point of the parabola going to the right. So it means that all the part that is to the left is not relevant. The function is only defined for values of x that are greater than c. So all we need is to find the minimum point. We can deduce the minimum point from the completed square format of the function. So we obtain the function f of x in completed square form as x minus 2 squared minus 1. So we're saying, since f of x is x minus 2 squared minus 1, then the minimum point is, we can deduce it from here, that will be minus of this number, so that's 2, and we take this number here to be the y coordinate. So this here is the minimum point of f of x, which therefore means that the domain is defined for values of x greater than c, where c is the minimum point or minimum x value. So x should be greater than the x value here, which is 2, and therefore the minimum value of c should come out as 2. And that's the answer here to part B. Let's scroll down to part C. It is now given that c is equal to 5. Find an expression for f inverse of x and state the domain of f inverse. So we have our f of x as x minus 2 squared minus 1. We can write that as y is equal to x minus 2 squared minus 1. And here I'm going to try to make x the subject. So I'll add 1 to both sides. So y plus 1 is equal to x minus 2 squared. And I'm going to square root both sides. So I'll square root here and square root here. This means that I'll be left with x minus 2 here. And here we'll be having plus or minus square root of y plus 1. So eventually we get x coming out as adding 2 to both sides. That will be 2 plus or minus square root of y plus 1. And then if we interchange variables, we're going to get y being equal to 2 plus or minus square root of x plus 1. So that means, therefore, that f inverse of x is going to be 2 plus or minus the square root of x plus 1. But now you need to understand something. From the question here, the function f of x is defined for the domain x is greater than c. So let me take this here because it's important. So this is the function right here. And on this part, they say it is now given that c is equal to 5. So it means that the domain is now x is greater than 5. Now, what you need to understand is that the domain of the function is comparable to the range of the inverse function. And what that means to us is that if the domain is x greater than 5, that the range of the function f inverse will be f inverse of x is greater than 5. So it means that the f inverse of x is defined when we have 2 plus square root of x plus 1. So this here is the inverse. Now for the domain of the inverse function, you need also to understand that the range of the function is comparable to the domain of the inverse, which is the one that we're looking for. Which means for us to find the domain of this inverse function, we have to know what the range of the original function is. Now we know for certain that the graph of the function f is a U-shaped parabola, and we have the minimum point at 2 minus 1, but now the domain is x is greater than 5, which means 5 can be a point somewhere around here. So because of this domain restriction, the other part of the graph is no longer defined. So the graph is only defined when x is greater than 5. And when x is equal to 5, what is the y value if we are going to look for it to get the domain? To get the y value here, we only have to substitute 5 into the original equation. So when we have f of x is equal to x squared minus 4x plus 3, that will be the y value is x squared, that's 5 squared minus 4 of 5 plus 3, that's 25 minus 20 plus 3, so we get 8, which means 8 is the minimum y value. So the range of the function is therefore y is greater than 8. So this range of the function is comparable to the domain of the inverse. So if the range of the function is y is greater than 8, then the domain of the inverse should come out in terms of x as x is also greater than 8. And this now is the inverse and domain of the inverse. And that's how we do it. Let us now scroll down to part D. Find an expression for g f of x and state the range of g of f. So here, this is a composite function, g of f of x. And we know from the question that the function g of x is defined for 1 over x plus 1. So let's take this. And put it here. So we have information that g of x is 1 over x plus 1. So when we have g of f of x, it means that f of x is an input into the function of g, which means that we can have 1 over x, which is the input. So that will be f of x plus 1. And f of x in completed square form, we got it as x minus 2 squared minus 1, and that will be plus 1. So we can simplify this to 1 over, and that's x minus 2 squared, and minus 1 plus 1 is 0. So g of f of x is 1 over x minus 2 all squared. Now for the range of g of f, we know that f of x is an input into the function of g. And we know that f of x has a range which we obtained on part C as the range of f is y is greater than 8. So we know here in this case that f of x is always going to be greater than 8. Now if f of x is greater than 8, and we know that g of f of x is equal to 1 over f of x plus 1, it means that we can actually find the range of g of f of x using the fact that f of x is going to be greater than 8. So I'm going to equate f of x to 8. So g of f of x here will come out as 1 over 8 plus 1, which is 1 over 9. So we know for certain that 1 over 9 is one of the limits of g of f of x. But let us now also consider what happens to g of f of x as f of x increases or approaches positive infinity. So as f of x increases, thus f of x is denoted by 8 here. As it increases, it means that the denominator here also increases, which means 1 over an increasing number here means that g of f of x will approach 0. Because if we divide 1 by an increasing number here, it means the whole thing, or g of f of x in this case, will approach 0. So we now have the limits here for g of f of x, which are 0 to 1 over 9. And that's the answer here to part D. Question number 11. The functions f and g are defined by f of x is equal to x squared plus 3 for x is greater than 0, and g of x is equal to 2x plus 1 for x is greater than minus a half. So on A, they say find an expression for f of g of x. So we're saying here, when we have f of g of x, it means that g of x is an input into the function f. Now the function f is such that f of x is equal to x squared plus 3. So in place of x, we have g of x. So it will be g of x squared plus 3. So this therefore means that f of g of x should be equal to g of x, which is 2x plus 1 squared plus 3. So this right here is the expression for f g of x. We might also need to know what the domain of f of g of x is. Now, since we're saying g of x is an input into f, and f is restricted for the domain x is greater than 0, so it also means that g of x should be greater than 0, which therefore means that g of x, which is 2x plus 1, should be greater than 0. And solving this inequality, we get x being greater than minus a half. So the domain of f of g of x is x is greater than minus a half. Let's go to part B. Find an expression for f g inverse of x and state the domain of f g inverse. So here we're going to say let f of g of x be equal to y, which therefore means y is equal to f of g of x, which we got to be 2x plus 1 squared plus 3. So from here, we're going to make x the subject. So this is going to be 2x plus 1 squared is equal to, subtracting y from both sides, that will be y minus 3. And from here, if I square root both sides, then it means I'll be having 2x plus 1 is equal to plus or minus the square root of y minus 3. Now, if I want to remain with x here, I will subtract 1 from both sides and divide both sides by 2. So I'll be having x is equal to minus 1 plus or minus the square root of y minus 3, all divided by 2. So we've made x the subject right here. Now, I would want you to notice that the function fg is restricted for the domain which is to the right of the axis of symmetry, which is x is greater than minus a half. Now, this means that we are going to take x is equal to minus 1 plus square root of y minus 3 all over 2 for that reason, since x should be greater than minus a half. Now we can interchange the variables, so that would be y is equal to minus 1 plus square root of x minus 3 all over 2, which therefore means fg inverse of x should come out as minus 1 plus the square root of x minus 3 divided by 2. So this here is the expression for fg inverse. Now they say state the domain of fg inverse. Now you need to understand that the domain of the inverse function is equal to the range of the function. Now if you consider the graph of the function fg, you find that it's a parabola with a minimum point at minus half and 3. And the range of the function fg is f of g of x is greater than 3. Now, since the range of the function is equal to the domain of the inverse, we can also say that the domain for this inverse is x is greater than 3. And that's how we find the domain of the inverse function. Part C. Solve the equation f of g of x minus 3 is equal to g of f of x. So here, the first thing that we can do is to first find g of f of x. Since f of g of x, we already have it. So for g of f of x, if you look at our functions, so I'll just place them here. So when we say g of f of x, we're saying that we're inputting f of x into g. That will be 2 of f of x plus 1, which is 2 of x squared plus 3 plus 1. So that's g of f of x. So when we say f of g of x minus 3 is equal to g of f of x, we're saying f of g of x, we got it to be 2x plus 1 squared plus 3. So that's 2x plus 1 squared plus 3. And that's going to be minus this 3 is equal to g of f of x, which is 2 of x squared plus 3 plus 1. Now 3 minus 3 gives us 0. And expanding this bracket, we get 4x squared plus 4x plus 1 is equal to, expanding here, we get 2x squared plus 6 plus 1. Now, taking all the terms to one side, we have 4x squared subtracting 2x squared to get 2x squared. And we have the 4x here. And we have 6 plus 1, that's 7. And 1 minus 7 is minus 6. So everything is now equal to 0. So we can factor out 2 here, and we get x squared plus 2x minus 3 equal to 0. Factorizing, we get x here and x here, and factors of minus 3, whose sum will give us 2. We have plus 3 and minus 1, which therefore means either x plus 3 is going to be equal to 0, or x minus 1 is equal to 0. Here we'll get x coming out as minus 3, and here we'll get x coming out as 1. But since our functions are defined for values of x that are greater than minus a half, we can therefore take x to be equal to 1. So the solution to this equation is x is equal to 1. Question number 5. The functions f and g are defined by f of x is equal to 4x minus 2, for x is an element of all real numbers, and g of x is equal to 4 over x plus 1 for x is an element of all real numbers and x is not equal to -1. So on A, find the value of f g of 7. So here we can start with g of 7, and g of 7 is 4 over 7 plus 1, which is 8. So that's a half. So when we now say f of g of 7, it's like we're saying 4 of g of 7, which is a half, minus 2. So this should be 2 into this gets into this 2 times, and 2 minus 2 is 0. So we get fg of 7 coming out as 0. Let's go on to part B. Find the values of x for which f inverse of x is equal to g inverse of x. Let's start with finding f inverse of x. So y is equal to 4x minus 2, and we make x subject, so x is equal to y plus 2 over 4, and therefore this translates to the inverse, coming out as x plus 2 over 4. We can do the same for g inverse. So we say y is equal to, the function g is 4 over x plus 1. So we make x subject. So that's multiplying, that's xy plus y is equal to 4. And thus xy is equal to 4 minus y. So that means that x is equal to 4 minus y over y. And if we interchange the variables, eventually we'll get g inverse of x coming out as 4 minus x over x. So we can now equate. So that's x plus 2 over 4 is equal to 4 minus x over x. Cross multiplying, we get x squared plus 2x, and on the right side we've got 16 minus 4x, and bring everything to one side, we'll be having x squared plus 6x minus 16 is equal to 0. And factorizing, we have x here and we have x here, and we'll be having plus 8 and minus 2, which means that either x plus 8 is the one that's equal to 0, or x minus 2 is the one equal to 0. So x comes out as minus 8 and x comes out as 2, and these two here are the two solutions to this problem. Question number 6. The function f is defined by f of x is equal to 2x over 3x minus 1 for x is greater than a third. So on A, find an expression for f inverse of x. So here I'm simply going to say let y be equal to f of x, which is 2x over 3x minus 1. So I'll make x the subject. So I'll multiply both sides by 3x minus 1. So this side by 3x minus 1, and this side again multiply by 3x minus 1. So I'll be having y of 3x minus 1 on the left side is equal to, this will cancel, so that'll be 2x here. So I'll be having 3xy minus y is equal to 2x. So that's 3xy, and taking 2x to the left side, we'll be having minus 2x, and I'll take y to the right side, becomes y. And I factor out the x, so it's now 3y minus 2 inside the bracket, and that's all equal to y. Which therefore means if we make x the subject, dividing both sides by 3y minus 2, we'll be having y over 3y minus 2. So if we interchange the variables, we'll now be having y coming out as x over 3x minus 2. So therefore, the expression for f inverse of x comes out as x over 3x minus 2. And that's the answer right here. Let's scroll down to part B. On part B, it says, show that 2/3 plus 2 over 3 of 3x minus 1 can be expressed as 2x over 3x minus 1. So here, we are saying, if we have these two fractions here, we can add them up by first finding the common denominator. And the common denominator here is 3 bracket 3x minus 1. So 3 dividing it into this denominator, we get 3x minus 1 and we multiply that by 2. So we have 2 of 3x minus 1. And that's plus dividing this 3 of 3x minus 1 into the denominator, which is 3 of 3x minus 1. We get 1, and 1 times 2 is 2. So let's simplify this. Simplifying the bracket, we get 6x minus 2 plus 2 there. And then that's over, at the bottom, 3 of 3x minus 1. This is going to give us, here we've got 6x, because minus 2 plus 2 is 0. And at the bottom, we have 3 of 3x minus 1. Now 3 divides into 6 2 times, so that we are left with 2x over 3x minus 1, and hence shown. Let's go to the last part, which is part C. On part C, state the range of f. Now the function f from the question is equal to 2x over 3x minus 1. And on part B, we had shown that this is equivalent to 2/3 plus 2 over 3 of 3x minus 1. So in order for us to determine the range of this function, we can say as x increases tending towards infinity, what happens to f of x? Now I think you can notice, if you look at this expression, that as x increases, you see that this whole fraction will tend towards 0. Since as the denominator continues to increase, holding the numerator constant leads to the whole fraction tending towards 0. So we can therefore say f of x will approach the constant 2/3 plus this thing will have a limit of 0. So we have a limit here for f of x, which is 2/3. So we can say that the range of the function f is going to be f of x having a value that is greater than 2/3. So that's the answer right here for part C.